let's work on a old free response question, right? So we should have hopefully already taken a look at this. I would give these a try first because we're not too beginning of the unit kind of stuff. When you're getting led to stuff, we should be, trying to do these on our own. This is an old AP question from 2018, not that long ago. Pretty fair question in my opinion. I don't think this is overly challenging or hard or anything like that. I think it's it's got a lot of the regular things in it. Anyway, so question 6 on the free response. Student sets up this galvanic cell at 298 C. You've got silver immersed in a silver solution, a chromium immersed in a chromium solution, as this diagram is showing. And then it says, a couple of things I notice as I'm reading, right? So like when I'm reading a gas laws question, I'm kind of paying attention to my units going to be an issue. Do I have to cancel something? Do I have is it a Pivnert problem and I have a temperature that, or not of course temperature has to be in Kelvin for a gas laws problem, but like a pressure, not in atmospheres or something. So as I read through this, I'm noticing my concentrations. Are my concentrations 1 molar for my solutions? Is it like the same, chromium in a chromium solution, silver in a silver solution, those kinds of things, right? So I'm not thinking this is going to be a Nernst issue because that's something I'm trying to keep an eye on as I go through. But then question A says, a student measures the voltage of the cell shown above and discovers that it is 0. Identify the missing component of the cell and explain its importance for obtaining a non-zero voltage. So we look at this. We've got a wire and a voltmeter and all that kind of stuff shown, but what we are missing is a salt bridge, right? So we're missing a salt bridge. So we would need to say, we're missing a salt bridge, but they also say, and explain its importance for obtaining a non-zero voltage. So what we would want to say is, as the electrons go from the anode to the cathode, they are bringing a negative charge. You need a charge balance of bringing positive ions then towards that cathode, right? So as you might work ahead and figure out which one's the anode and the cathode. So you say, as electrons flow towards chromium or whoever they're going to flow towards, you would need positive charges to flow in that same direction. Or you could say something effective, whatever direction the electrons are going to flow, that's going to bring a negative charge. That's a charge imbalance. You would need positive charges to flow in that same direction, right? So something along the lines of charge imbalance, of electrons flowing somewhere and needing to balance that out with positive charges, right? So a student adds the missing component, a salt bridge. They don't tell us it's a salt bridge, but and it turns out to the total voltage is 1.54 volts. 1.54 volts. We know silver is 0.80, written as a reduction potential. So silver plus an electron makes silver, gives us a positive 0.8. So that means that my chromium, written as a reduction potential, is probably, right? So this plus chromium. I took a second and rewrote stuff so we can see it a little easier, right? The chart that they gave us had both the reduction potentials, but it was missing chromium's reduction potential. They ask in here, calculate the delta E for chromium's reduction potential. But as soon as I see this, I know chromium is not getting reduced. Chromium's getting oxidized because 0.8 here, I need something that's a positive here also. So the 1.54 minus 0.8 is going to give me this part of it must be 0.74. But since silver is being reduced as a positive, then chromium must be being oxidized, right? So silver is being reduced. This is the cathode. This is the anode. So we are going from chromium to chromium plus 3, and we're going from silver plus to silver, right? Electrons are getting generated at the anode. They are going to the cathode. So then we would now know, right, since my electrons are oxidation is happening at the anode, lose electrons oxidized, we lose those electrons, they go towards the cathode. So we have electrons going this way. So back in this one, we would need positive ions flowing this way. We're losing negative charge over here, so we would need negative ions flowing this direction, right? Going back to that first one. But in any event, this must be a negative 0.74 volts, right? Because what we're actually doing is the reverse of that. Write the balanced net ionic equation for the overall reaction that occurs as the cell operates. So I'll kind of go off of this guy. Chromium, we know we're going to have to triple this one. Plus 3 Ag pluses yields 3 Ag plus CR plus 3. And we have a bunch of extra junk here. Right, so I would need to triple my silver. There we go. Calculate the G value for this, for the overall reaction in joules per mole. So we'll reset for the last part of that, right? Our delta G equation, delta G equals negative NFE. Remember, this negative is here because a positive E is spontaneous and a negative G is spontaneous. So that's showing us direction. Since we had a positive E, we know that this is going to give us a negative delta G. So as we just go ahead and plug this in, this part of it's not too tough. Negative N, right, or negative, and then N is the number of electrons that we're dealing with here. Well, it says per mole of electrons, or per mole of reaction. So in our balanced redox equation, we had 3 electrons there. So we'd say 3 moles of electrons times Faraday's constant, which is 96,500 joules per volt, times 1.54 volts, right? It was 1.54, wasn't it? Yep, 1.54. So we multiply those together, and that gives us 4.4, a negative 4.45 times 10 to the 1, 2, 3, 4, 5 times 10 to the 5th joules per mole. They say joules per mole there, so I'm not going to change it, even though standard for delta G is kilojoules per mole. I'm sure they wouldn't count off if you did change it to kilojoules per mole, but since they asked for it in joules, we should go ahead and leave it in joules. Anyway, so that's that. If you have any other issues, stuff that you want, extra practice problems you want to work or whatever before the test tomorrow, jump onto the Google Meet and we can do that.